All right, here we have notes I, scientific notation, and an example of a number in scientific notation, 3.9 times 10 to the fourth power. So what makes this scientific notation is this number here is between 1 and 9. Same thing as to say the number to the left of the decimal is between 1 and 9. That's a 3, and that's between 1 and 9. Then we always have, to the right of that, 10 to the power of an integer, like 4, -4, even 0. So the right side is always times 10 to some exponent up here that's positive or negative or 0. Okay, let's look at some facts that will help us work with numbers in scientific notation. This is one fact, that if we multiply a number by 10, the decimal moves once to the right. So this number times 10 becomes 10 times bigger, and that's the same as moving the decimal once to the right. If we divide by 10, it essentially moves the decimal once to the left. It makes it 10 times smaller over here. So dividing a number by 10 makes the decimal move once to the left. Remember to pause the video when you need to copy some things down, and rewind if you'd like to hear some things over again. Okay, so let's look at this trickiness on the right side here. There are some things that are the same. When I say divide a number by 10, yeah, that might look like divided by 10. But multiplying by 1/10 is the same as dividing by 10. And the same as 1 over 10, we just learned, is 10 to the -1 power. So when we see times 10 to the -1, we need to think, oh, that's dividing by 10. That's moving the decimal once to the left. That's super tricky. Now if we have times 10 to the -1 and we want to do that 6 times, so divide by 10 6 times, we have this. Times 10 to the -1 to the 6th. That means dividing by 10 6 times, and here it is in an example. And again, pause the video to copy this stuff down. So 2.4 times 10 to the -6th, that's in scientific notation. This number is between 1 and 9, check. And we have times 10 to an integer power. And again, interpreting this means we're dividing by 10 6 times. So that means moving this decimal to the left 6 times, and that's what we see right there. If it was times 10 to the +6, then it's not that tricky. It's what it looks like. We're multiplying by 10 6 times, and we'll move the decimal to the right 6 times. It will look like that. Or it turns into 2,400,000. Okay, so times 10 to the negative number is like dividing by 10 a number of times, it moves the decimal to the left. Times 10 to the positive number means multiplying by 10 a bunch of times, moving the decimal to the right. And to show that it is to the right, let me make that look more like an arrow, and this went to the left. Okay. And this is just stating what happened. Go ahead and write that down. Pause if you need to. The decimal was moved 6 times to the right because we multiplied by 10 6 times. The decimal was moved 6 times to the left because we divided by 10 6 times. All right, let's look at some examples where we write numbers that are in scientific notation into decimal form or standard form, same thing. All right, on the left side, we have 3.1 times 10 to the 5th means times 10 5 times. So we got to move the decimal to the right 5 times. It'll go once over the 1, and then we need 4 more zeros, and you end up with an invisible decimal right there at the end. So we had the decimal here, and we went 1, 2, 3, 4, 5. And then you don't really write the decimal at the end. So you just have 310,000. You could put a comma in there if you want. And let's do that. Here, 1.32 times 10 to the 8th is multiplying by 10 8 times. So the decimal goes to the right 8 times. 1, 2, and then 6 more, needing 6 zeros after that. Like that. So the decimal was here, and it went 1, 2, 3, 4, 5, 6, 7, 8 times to the right. Now it's right there. Not usually written though. So we can put in some commas. It's 132 million. 4.3 times 10 to the 1 moves the decimal once to the right because we're multiplying by 10 once. For 43, the decimal was there and it moves there, so it's just 43. On the right side here, remember this means we're dividing by 10 5 times. So we're moving the decimal to the left 5 times. Now when we move the decimal to the left, it'll look like that because the decimal was between 3 and 1, and then we move it 1, 2, 3, 4, 5 times to the left. That's how we get that. Here we're taking a decimal number and moving it, the decimal 8 times to the left. So it's once over the 1 and then 7 zeros. And here we definitely need the decimal there on the left side. So the decimal was here and we went to the left 1, 2, 3, 4, 5, 6, 7, 8 times. All right, here we move the decimal once to the left to get 0.43. The decimal was here, we moved it once to the left and get that. All right, now we'll start with these numbers in decimal notation or standard form and write the numbers in scientific notation. In reverse, we want the number to the left of the decimal to be 1 through 9, like all these. We want these numbers to the left of the decimal to be 1 through 9. That's our goal. You can see these are all 1 through 9. So pause the video and copy these down, and then we'll try it out. Okay, here, the decimal is currently at the end, and we want the decimal, so to the left of it is 1 through 9. So we want it to be 1, 2, 3, 4, 5, 6, right there, because the number to the left of the decimal is now 1 through 9. It's 2. That works. So 2.6 times 10 to the, this is tricky, to go from this side to that side, we'd have to move the decimal 6 times to the right. So that's a positive 6. Times 10 6 times would do it. Here, the decimal needs to be there, since to the left of it is 1 through 9 now. It's a 4. That works. It's 1 through 9. But now that it's 4.5, to show that it's actually quite a large number, we'd have to move the decimal 3 times to the right to get what it really is over there. So moving the decimal 3 times to the right is times 10 to the 3. Okay, here we need the decimal there, so that again the number to the left of the decimal is 1 through 9. It's 2. That works. So 2 through 9, 2.9 times 10 to the, from here the decimal would have to go once to the right to get back here to 29, so just 1 up there. Okay, do a few more examples and then that's it. Okay, here we have a number not in scientific notation yet, but if we move this decimal once, twice, 3, 4, 5 and stop there, we're done because now 1 through 9 is to the left of the decimal. 8.3. Oops, 8.3. Times 10 to the, now to get from here to there, we'd have to move the decimal 5 times to the left. So times 10 to the negative 5. Let's try this. Where does the decimal need to be? Right there, 7.41. Then the number to the left of the decimals between 1 and 9. And so is the whole thing here. Times 10 to the what? Well, from here to there, we'd have to move the decimal to the left 4 times. So negative 4. You can also remember, usually tiny numbers go with a negative exponent up here. And big old numbers go with a positive exponent. That's almost always the case. So 0.2, we need the decimal so that to the left of it is 1 through 9, so it needs to be right there. So to the left of it is a 2, which is 1 through 9. And you could put 2.0. But it came from here, and to get there, you'd have to move the decimal once to the left. That's times 10 to the negative 1. Okay, that should help you, and remember, I'm always available at lunch. Well, I'll say usually available at lunch, and after school if you need any further assistance.